How's it going, guys? This is a video lesson for today because I am out of the building. And what we're talking about today is graphing linear inequalities, okay? Our goal is to be able to mainly graph these, but also write them. But today we're going to focus mostly on the graphing part, okay? You'll recall we already know how to graph regular inequalities that are in the form y equals 3. But now we're going to transfer it into linear inequalities, and linear should be a tip-off. We're going to be talking about lines on an xy coordinate plane here. All right. A couple things that we need to remember. Linear equations are in two different forms that we have discussed so far. One of them is slope-intercept form, and the other is standard form. Okay, and here's an example of things that we did. Remember, this is our slope, this is our y-intercept, or our beginning, and we would start on the graph like y is equal to 4, and we would start here on the graph at, and we would use this number to find our next point. Remember, this is really 2 over 1. So we would start at, if 4 is on the graph here, we'd start here, and then we'd go up 2, right 1, up 2, right 1, and we'd have this line for the graph. Remember, our strategy for graphing these in standard form was to just make XY chart. All right, so we have our two strategies. What we're going to do today is, instead of having equations, we are going to have inequalities. Basically, all we're doing is replacing the equal sign with one of these inequality symbols. That's it, okay? So, for example, if I want to compare linear inequalities to linear equations, if we're using the slope-intercept form, this is the slope-intercept form of a linear inequality. If we want to talk about standard form, this is the standard form of a linear equation. So a linear inequality. So those are what the two look like. Really, the only difference is here in terms of what the equations and inequalities look like is the symbol. Okay? We know how to graph all of these. We should know how to graph these. And today we're going to talk about how to graph these. By the way, you already know how to graph 90% of this, okay? It's very much the same except for one or two different things, all right? So, remember when we talk about solutions to regular inequalities, okay? When I graph a regular inequality, like y is greater than or equal to 12, I'm sorry, 3, I would put, 3 here. This is a filled-in circle. And all of my solutions are on this side, right? So I'd have a filled-in inequality here, and all of these would be considered solutions, including 3. All right. Remember, notice I have a equal sign here on the bottom, so I fill in my circle here. Whereas if I didn't, I'd have an open circle, right? If I'm talking solutions for a linear inequality, instead of having just one variable for a solution where my answers can be like 4, 5, 6. Anything greater than 3, I can have pi as an answer, right? Instead of just values for y, I get answers that are an ordered pair, okay? And these ordered pair solutions give me a true statement when I plug them into the inequality. Just like if I were to plug 4 in this, that would give me a true statement, okay? So, a couple of example questions that you're going to have tonight. Determine if 2, 6 is a solution to this linear inequality. Well, all I'm going to do is plug that in. This is an x, this is a y. So I'm going to say that 6 is greater than or equal to 2 times 2 minus 1. And I'm just going to simplify this. 6 is greater than or equal to 2. Greater than or equal to 2 times 2 is 4 minus 1. So I have 6 is greater than or equal to 3. That's true. So that means 2, 6 is actually a solution to this linear inequality. All right? Now, let's get down to this business about graphing inequalities. I'm going to have you guys write down the steps because right now I'm not going to actually show you. I'm going to go through the steps. I want you to write them down, pause if necessary, okay? And then we'll put it all together and put it into action. Okay, and we're not going to do this right off the bat. The first thing we want to do is to determine if the line is part of the solution, okay? So what that involves is looking at each of these symbols and saying, all right, if I have a less than or equal to or greater than or equal to symbol, that means I graph a solid line, okay? Remember before, these symbols would give us a solid circle. So now we get a solid line in the graph. All right. If I have a less than or greater than symbol, that means I have a dotted or dashed line, which should be kind of clear to see that it relates to the open circle that we used to graph on the number line. Okay, so the first thing is to basically look at your inequality and say, all right, yep, I got, if we look at this inequality here, I would say, all right, my line that I graph when I go about graphing it is going to be dotted in this case. Okay, all right, moving on here. The second step is to then graph it if it was a normal equation. Okay, it says graph as if it was normal y equals mx plus b or standard form. Okay, so just to review, if we have slope-intercept form, remember we start at the y-intercept. That's our starting point. And we use rise over run to find the next point. Okay, so we use rise over run. So if my slope is 1/2, that means I go up 2 and right. I'm sorry, up 1 and right 2 to find my next point. All right. If instead I have standard form, then I would still graph by making my XY chart where I choose my zeros here and here, and then find out what my other values are for my points. Okay, so far, the only steps that are different than anything that I know is, okay, determining what kind of line that I graph. All right, and then all I do is graph it normally and then make sure I pay attention to a solid or dashed line. All right, now my last step says which side of the line do I shade. Okay, now let's go back for a second. When I graph something like y is greater than or equal to 3, I had shading that I did, right? Well, that's no different than the shading that I do for a linear inequality, all right? But this is how I do it. We use a test point, and typically we use 0, 0, and we plug it in for x and y, all right? Then, so like, if this was the inequality that I'm going to use, I would say, well, actually, let me go through the steps for graphing this, okay? First, remember it says determine if the line is solid or dashed. Well, I have a dashed line here. And then graph it as normal. So my y-intercept is -1. -1 is right here. My slope is 2 over 1. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. Okay. And then I'm going to make sure I graph a dashed line. And I'm going to try to do that the best that I can here. It's kind of tough. But that's my dashed line. All right. Then it says determine which side to shade. All right. It's telling me to use a test point 0, 0. Notice 0, 0 is right here. So I'm going to plug in 0, 0. And instead of y, I'm going to write 0. Instead of x, I'm going to write 0. And I'm going to simplify. 0 is less than 2 times 0, which is 0, plus 1. Simplifying, I got 0 is less than 1. My next step is if I get a true statement, shade with 0, 0. Is this true? Is 0 less than 1? That is true. So I'm going to shade this side of my line. Okay? If I got a false statement, I shade the other side. Okay? Now I know that's a lot. Pause it if you need to go back, but we're going to go through a couple of examples here. All right. So I have one in y equals mx plus b form. So I'm going to go through and graph it normal. Notice my line is going to be solid. All right. And I'm going to start at 2. And I'm going to go down 1, right 2, down 1, right 2. And I'm going to graph a solid line. Down 1, right 2, down. Oh, sorry, wrong point. Let me go back here. Made a mistake there. That's right. Starting here, down 1, right 2, down 1, right 2, and that's my line. There we go. That's better. All right, solid line, like I said. Okay, and now my only step is to determine which side of the line to shade. So I have this point 0, 0 here, and I'm going to plug that in for x and y. So I have 0 is less than or equal to -1/2 times 0 plus 2. Or simplifying, 0 is less than or equal to 0 plus 2, or 0 is less than or equal to 2. Is that true or false? Well, that is true, so I shade the side that has 0, 0. If it was false, then I would shade the other side. All right, next one. I want to make a t-chart for this. So x, y, 0, 0. All right, if I plug in 0 for x, 4 times what gives me 12? Well, that's going to be 3. If I plug in 0 for y, negative 6 times what gives me 12? Well, that's negative 2. So I graph these 2 points, 0, 3, negative 2, 0, and I have a dashed line. So here's my dashed line. Okay, and now I test the point 0, 0. If I plug in 0 for y, 0 for x, really I have 0 is greater than 12. Well, that's obviously false. 0, 0 is right here, so now I shade the other side of the line. All right, last example here. Let's see if the computer keeps cooperating with me. I'm going to graph the line, the linear inequality, y is greater than or equal to negative 2x. All right, what's my y-intercept? Well, remember, I can add plus 0 here if I want, but I don't need to. But that means my y-intercept is 0. And my slope is negative 2 over 1, so down 2, right 1, down 2, right 1. And my line is solid. So here is my solid line. And now, here's the thing. I cannot use the test point 0, 0. 0, 0 is on the line. If that's the case, you can't use it. So then I'm just going to pick another point. I'm going to pick the point 1, 1. Okay? So I'm going to plug 1, 1 into this linear inequality. So I'm going to transfer this work down here. 1 is greater than or equal to negative 2 times 1 plus 0. Or 1 is greater than or equal to negative 2 plus 0. Or 1 is greater than or equal to negative 2. Is that true or false? Well, obviously this is true, so I shade the side that has 1, 1. So I'm shading this side of the line. All right, that's how you graph linear inequalities, guys. If you have questions, please make a note of them and ask them on Monday. Remember, this video is on my webpage and on YouTube, so you can watch it over and over again. Have a great weekend, and I'll talk to you later. Peace.